All right, so I'm gonna move this as it jerkily goes. Okay, now you can see me, yay! All right, so remember, this is gonna take two on greatest common factor. Seeing the feedback, yes, I had an error, I went back and fixed it, but maybe this time we'll go through and it'll be awesome. So our learning target is factoring out the greatest common factor. As you're watching the video, make sure you're using twice the video's length. Again, you can speed it up, and you're pausing. These are notes to your future self, so if you have questions, you can put them in the comment section below in the Loom video if you're watching it on Loom, and then pause, rewatch, and there's other resources there. And then after the video, make sure, did you focus? Did you highlight anything? Should you go back and circle something or box something or put a sticky note or email me saying, hey, I totally don't know how to do this, or this is where I got stuck. Can you help me tomorrow in class? That would be awesome. Or I can email you back and reply and help you out. So, take two on greatest common factor. Oh no, there we go. I'm back. So, in your table of contents, it's probably not this page, it's probably page 1 because we're starting first semester, or second semester. So, greatest common factor, page whatever number you're on. So, put that page number in there. I'm going to look at my old notes while I do the new notes. So, notice that my new notes are not on lined paper, but they are similar. They are going to be similar to the first one. So we're going to define what a factor is. We're going to go over examples of using GCF and identifying it. And then we're going to have 2 examples of actually factoring it out. And I'm going to try to go slower and actually be clearer on what does it mean as a verb to factor out something. So we're going to start with defining the word factor. So I will pause. All right, so this is what the definition of a factor is. A factor is a number or algebraic expression that divides another evenly. And I'm going to see if this is the focus button. Oh, okay, so it divides another evenly. And then I want to also put that up to now, I've given you something like 2x plus 3, or I'm going to put a 5 in front, and x minus 1. And then the answer to that question would have been, 5 times 2x squared minus 2x plus 3x minus 3. Distribute and combine like terms, so 10x squared plus x, so plus 5x minus 15. Okay, so before this unit, or before even this lesson, I would have given you this as a question, and this would have been the answer. This whole unit is how do we go backwards? How do I take this answer and how do I find the factors? Notice that 5 is a factor of this algebraic expression or polynomial. Notice that 2x plus 3 is a factor and x minus 1 is a factor. All right, factors are all the things that divide another thing evenly. You're going to do polynomial division in Algebra 2. We're not even touching that. So, stress me that these would actually divide into this because when they multiply out, they all get this. So, an example of that is, what if I had 5 times 2 times 3? These are all prime factors. So, what's 5 times 2? Times 3. That gets you 30. 5, 2, and 3 are all factors of 30. If I factor out this 3, so if I do 30 divided by 3, because factors divide evenly, what is 30 divided by 3? 10. That leaves me with the 2 times 5, the other factors that are left. So if we divide by factors, we've pulled them out. When we divide by factors, we're pulling them out. We're factoring them. So thinking about that, let's get into some practice of finding the greatest common factor. So if I have 3x squared and 15x to the 4th, what are the factors that make up each of these expressions? Well, 3 is just 3. Technically, there's a bunch of 1s in there. 3 times 1 times 1 times 1 times 1. But we don't have to put the invisible 1s. And then there's an x and another x. You can put the dots if you want. It takes more time, so as you do this more eventually, I probably wouldn't put as many dots, but you can. 15. Those prime factorization would be 3 times 5 and I would have 4 x's beyond that. I like to put the dots between the prime factors just because you can tell it's not 35. It's 3 times 5, and then a bunch of x's. So these are all the factors. 3 times x, all multiply out to make 3x squared. This is a factor, this is a factor, this is a factor. Now I want the common factors. Ooh, they both have 3's, they both have x's. Now, I want the greatest common factor. What is the most that I can divide by that is the greatest in common? So they both have 3's. They both have 1x. And look at that, they have another x as well. So the greatest common factor, the GCF, is 3x squared. Notice that if I divide 3x squared, this is off to the side, 3x squared divided by 3x squared. So the term that we're using, or the expression we're in, divided by a factor, hint all of its factors, will give you what? 1. So there is always an invisible times 1 at the end. If we don't see it, if you want to write it, you're welcome to. Okay, so I think I focused mostly on here that you should know what factoring out means and how to find the greatest common factor. Now we're going to go back and we'll go forward. We're building on this. We have 2 examples. Example 1 and example 2. Okay, so that's the rest of our notes, 2 examples. So we're going to first find the greatest common factor, and then we're going to factor out, or divide by, the greatest common factor. So, the first example, 36x to the 4th minus 42x squared. So first, I need to break these down into their prime factorizations. So I'm going to make a little tiny factor tree off to the side, and I have 36. It doesn't matter how you start this. You can put 12 and 3. You can put 2 and 18. You can put 9 and 4. Doesn't matter. So if I do 2 and 18, I get 9 and 2, 3 and 3. Notice that I'm stopping whenever I have a prime number. Nothing else multiplies to make 2 except 1 and 2. Nothing else multiplies to make 3 except 1 and 3. So the prime factorization of 36 will be 2 squared multiplied by 3 squared. There are 2 2's being multiplied, and there are 2 3's being multiplied. And then I have 4 x's minus. I'm going to do the exact same thing with that 42. So at 42, again, I have a factor tree. Here's the end of my paper if you want reference. So 42 will be 6 and 7. 6 is 2 and 3. And so I have all these loner primes. There's only one of them. So I'm going to come up here and I write 2 times 3 times 7, and I have 2 x's. This is the expanded form. Okay, I'll pause it up here. Then I'll move it down. The fan is blowing on my paper, so I didn't want it floating off the table. Okay, so I have them expanded versions. I'm going to do the same circle thing I did up here. Everything they have in common. So notice they have one of the 2's in common. They have one of the 3's in common, and they have 2 x's in common. Pause here if you need to. Do you see what they have in common? Do you see what they have as factors? 2 squared, 3 squared, x, 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 2, 3, 7, x, x. Technically, there's a negative 1 in there that we don't see. Okay, sometimes they could have a negative in common. In this case, they don't. So the greatest common factor in this case is going to be 6x squared. Pause here. Why is it a 6x squared? Why isn't it 2 times 3xx? This is a simpler way of writing 2 times 3 and x times x. So my greatest common factor is 6x squared. I'm going to put that on the outside when I write my factored form. This is the factored form. I'm using the greatest common factor to write this in factored form. Notice that factors all multiply, just like this 5 times 2 times 3. Just like this 5 times 2x plus 3 times x minus 1. Each of these are all being multiplied together, so there are 3 factors. This one has 1 term, this is a binomial, this is a binomial, but I have 3 factors. So in this case, I'm going to have 2 factors. I'm going to have the GCF and all the leftover stuff. So let's go look at all the leftover stuff. If I divide out 6x squared, I'm left with still a 2 and a 3, which make 6. And x, which makes x squared. So it's just coincidence that both of these are the same thing. They typically aren't. That's not a pattern. Next one. 2 and 3, gone. What's left? Just the 7 and that negative 1. So it's just minus 7. This is your factored form. All right, example 2. Same thing. And I'm going to take more time. Well, yeah. Okay. So 4x cubed y squared minus 20x squared y cubed plus 12xy to the 5th. Okay, 2 things. I'm going to show this using a different method. But I want you to still expand this. So take the time, pause, write this out. What is 4? What is negative 20? What is 12? Use your small factor trees and figure it out. All right, you should have expanded it like this. And now I want you to pause the video, and I want you to write down the GCF. So circle all the factors that they have in common, figure out what that is, and go. All right, so it's 2 squared x y squared. That should have been your GCF. Now, you could write it like we had before, write the GCF in the front, and then pick all the leftovers. I'm going to show a different way of showing that exact same work. All right, so I'm going to keep my GCF on the outside because that's still true. Notice that you know what 2 squared is. Write it as 4. Oh, I wrote it as 4 squared. Sorry. Okay, you know what 2 squared is. So write it as 4x y squared. That is the simplest way of writing it. This is my y, not a 4. And then I have parentheses. And yes, I know my face is in the way. I'm going to fix that. Okay. So, there we go. Hopefully less air blowing on it. Go fan. All right. So, because factors divide another evenly, I'm going to show that division. I'm going to divide each of my terms by 4xy squared. This is just another way of showing that work. So, if I take 4 divided by 4, that's 1. X cubed divided by x, x squared. Y squared divided by y squared, 1. And this is why we did the exponents unit before we did this unit. Because you need to know how do you divide exponents, variables with exponents, before you ever do this. All right? Negative 20 divided by 4 is negative 5. X squared divided by x is x. Y cubed divided by y squared is y. Let's see if I have enough room. I think I do. Positive. 12 divided by 4, 3. X divided by x, 1. Y to the 5th divided by y squared is y cubed. And that's a y. All right? So this is your final answer. So pick the method that you like best. Do you like circling and then just putting all the leftovers below? But circling requires you to have expanded. For GCF, I could have looked at this and thought, okay, 4, 20, and 12. What divides those? 4. Okay? Boom. Got a 4. I don't have to think about the 2 squared and the factor trees. I can just go 4. How many x's? Well, 3, 2, and 1. They only have 1 in common, so it has to have an x. And then 2, 3, 5 for y's. There are 2 y's in common, so I have 2 y's. All right? So that would be my thought process where I can just think it. I don't have to put factor trees down. I don't have to fully expand it. But if those strategies work for you, use them. They exist. If you don't like them, then maybe try a different strategy. There are many out there. You're going to see another one with the area model, doing the backwards method tomorrow in class as well. So then once I do the division, I wrote this down on purpose so I can visually see and I make sure that I'm doing it right. What is 4 divided by 4? What is x cubed divided by x? What is y squared divided by y squared? I am thinking that through each time. I'm not doing it in my head. Well, I'm doing it in my head, but I wrote it down here so I knew that I was dividing by the right thing. Okay, so that is the end of the notes. I know, pushing the, no! Okay, that's what I get for trying to do this so late. And PowerPoint, there we go. So, were you somewhere that you could focus? Was this take 2 version of notes better than the first take? What was nice about them? If I now have the first take up still, then great, you can go look at it. If I take down the first take, then maybe these are the only notes you have. But It's one page. I hope you understand what it means to factor out something, because we're going to build on that next with factor by grouping in the next video. So have a great day and see you later.